Hello, welcome to Releasing Ceph talk. Thank you guys for showing up. My name is Alfredo Deza, and I've been working with the Ceph team for a while now, 5-ish years, and I've been doing a little bit of everything. I've been a release manager for a few years. Now I share that responsibility with a few guys from RedHat and a few from SUSE who help us out every now and then for cutting releases. And yeah, so these presentations split between me and Ken Dreyer.
All right, thanks. My name is Ken Dreyer, and I work on the Ceph engineering team as well, along with Alfredo. And we are here to talk about building and releasing Ceph. So all security incidents are unique in their own way, and one stands out to me in particular. So in 2015, it was my first year at RedHat. I hadn't completed a year there, and I got invited into a meeting. And the invite said, "We need to talk." And I went into the meeting, and there were a couple people there from Red Hat Product Security, including Mark Cox. And Mark is the lead of product security at Red Hat. Something had gone wrong. So to talk about what went wrong, I'm going to back up a few more years to talk about how we were initially building Ceph. Initially, we had the code in GitHub, and we were building Debian packages and Ubuntu packages, and we were pushing those up to the Ceph.com web server. So we would index those, and then GPG sign those and publish them. And if you know about apt repository signing, basically that GPG key is what authenticates that the packages are coming from the Ceph project. So if you have that key, what that means is you are able to forge packages to make it look like they came from the project. Basically, when in those early days, we were building a lot of things and we were signing a lot of things for more and more distributions. And eventually we added CentOS 6 and CentOS 7 in there. And along with those platforms came a lot more packages and a lot more dependencies, a lot more build scripts, and a lot more processes that unfortunately were not quite written down. So we would end up building more and more things, and there were many, many bugs and problems with this process. So sometimes there would be bugs in Ceph, sometimes there would be problems with the build environment, different things, and we would just continually have to be building, pushing, signing over and over and over again. At one point, someone got the idea that in order to make this a lot faster, we would copy the GPG key that we use for signing onto the web server that was also running WordPress. So, yes, it got a little bit worse, unfortunately, because we also copied the GPG key onto every build system that was building Ceph. So in order to build it at the end, the job would sign the release as well, and then we'd collect that and push it. So by the end, we weren't quite, I'm not sure that anybody had a full picture of where the GPG key had been copied. And then a member of the public said, "Hey, I found your GPG key. It's on, I forget, was it the Mirror or on the website or something like that." Basically, it was exposed to the public. And, so we had, basically, long story short, we had to go through this exercise of generating a new, stronger key, keeping that on a very restricted system, and improving a lot more of the build system, the build and release process. So that's what we're going to talk about today. Alfredo.
So when Ceph started as part of the startup, we had to move like pretty quick. So things are like, in the case of the GPG key, it's like, how can we like make it faster and cut these releases and not make it a burden? put the GPG everywhere. And it was one of the things with the GPG keys was it didn't have a passphrase, so even worse. Because what happens when you have a passphrase? You have to actually put the passphrase in every time you're signing. Nobody wants to sign 30, 40 packages for multiplied by how many distros you're releasing. So there's a culture of if it fits, it ships, and keep on moving. What's the next thing on our to-do list, and get there. So a bunch of other things related to the specific way that we cut releases and we build. So I inherited a Jenkins server that basically wasn't using, the things that compose a nicely automation and continuous delivery system. It was just basically one node that had a bunch of scripts. A bunch of the problems are like right here. It was a lot of bash. It was monolithic, hard-coded scripts, not controlled by version control. It was completely undocumented, so you had to go in, try to figure out things, and see how they were built. And it wasn't clear how things were put together. So in the case of Ceph, some distributions needed certain dependencies and certain packages to be available, and somehow these packages would end up in the repo because part of the scripts depended on these packages. So say, for example, an RPM, and RPM would have to exist on this directory, and then would get pulled into the repo. But where did this RPM come from? What happens with the next version, like CentOS 7 to CentOS, from CentOS 6 to CentOS 7? What do we do now? Do we need to put like another RPM in that directory? So a lot of like those like question marks up in the air, and how to like this is what we were facing basically. So a lot of these was very frustrating, and we tried to stop and think, how can we go and try to take these pieces out and make it more consistent and more basically better. And one of the things that I want to touch here is that a lot of in a lot of these situations there's this thing called SMOP, which is a simple matter of programming. I don't know if you've heard the term. When I first heard it, I was like, oh man, that's happened to me a lot of times, where you say, well, like this is a pretty complicated system, and releasing Ceph is, not an easy thing. It's like, and someone will come and it's like, well, what do you mean? How about, in the case of the GPG, it's like, well, GPG signing is not difficult if you just copy the GPG key everywhere. It's like, well, okay, it's like, well, but what about the passphrase? Well, it's just as easy as not requiring the passphrase. So the simple matter of programming thing keeps applying to all of these problems. It's like whenever we face a difficulty in the road, in the path of like cutting a release or whatever problem we're trying to solve, it's inevitable to receive like an email or a message or a comment. It's like, well, like this could be really easy if we just make this change here. It's like, well, things can, get a little bit more complicated. So here's the old overview of how things used to work. So a Ceph branch would trigger a change. A Ceph branch on GitHub would trigger this continuous integration system. We had one server per distro. The same server would build, and the same server would make the repos, and the same server would host the repos. So that meant that you had one server for CentOS 6, another one for CentOS 7, another one for Debian, and another one for Ubuntu. And whenever one of these things was down, like the whole thing was down. Like, just like nobody could like, oh man, CentOS 7 is down. Like, oh, nobody can just test against CentOS 7. We're done. So the development cycle used this system that started getting into a bottleneck because basically it got piled up with a bunch of different branches and people were pushing. And then suddenly Ceph started becoming like more popular and more contributors and more people were allowed to push branches onto GitHub. And this caused the system to just bog down and not, be able to to produce the repositories that developers needed to test. It got to a point where you could wait for a day and a half for getting a repository after you push the change to GitHub, which was completely unacceptable. Now, so what ended happening was also that sometimes these servers would not work. They would have like, oh man, we're missing a dependency. So what do we do? Oh, well, let me SSH into this server over here, add the dependency problem fixed, we can continue the builds. Oh, okay. So, but who would get notified about these changes in dependencies? It was me when I was cutting a release and I had no idea, like something changed, and now I need to find where I'm going to put this RPM package because I have no idea where it came from. So to fix that, we made it. We tried to have these pillars of how we want to make this thing better. So make ephemeral hosts, not like static hosts that are like, this is the one CentOS 7 machine that nobody can touch. So it can go away, it can go up in flames, we'll bring another one and we'll continue our process. Put everything in version control, highly documented, remove like the tons of scripts and make it more concise. A lot of configuration management so we can have these repeatable deployments and move forward. We use Jenkins Job Builder, which I'll talk in a second, but and reduce the interaction of developers and the community into Jenkins, because Jenkins is the interface can be a little bit rough, and nobody really likes to know and understand and figure out how to get to what they really want, which is just the logs. Show me the logs if these failed, and how to get there. We made everything really, really push button. So for the development side of things, not only the simple interaction, which is, hey, I push the change on GitHub, I want my repository back, but we also made a lot of the infrastructure very elastic. So whenever there's a lot of demand, we start firing up servers on the back and to cope with the demand of building servers and building packages. And this all happens like automatically. We have some services that are checking how many nodes it needs to like produce the packages and be able to pull through. In all of these scripts and all of these configuration for all of these jobs are ephemeral. So, like I said before, it was just I'm going to SSH onto this one server and fix this script that has this syntax error, or we want to add another if condition because Ubuntu released a new version and it has a new dependency that we didn't have before. So we need an if condition to SSH here and fix it. So we made it ephemeral. So all of these things are just go away. After 15 minutes, you don't have a server. The first thing that happened was like a developer came and was like, well, I need to SSH into this server to fix this problem. And it's like, well, you can SSH, but it's just going to go away in 15 minutes. And it's like, how can I work like this if things just go and disappear after 15 minutes? So, well, you go, and here's a repository of all of our configurations and all of our scripts. And as soon as you make a pull request and that thing gets reviewed and gets merged into master, the jobs get updated and you can see the results. So it was a shift in thinking, how can we manage infrastructure that scales up? So the other portion of this is that we have this huge dashboard. If you've ever contributed to Ceph, you might have looked at this. It's called shaman.ceph.com, and it's an HTTP API and a dashboard and a load balancer. So all of our systems are pushing information here, so we know how many builds, how many repos, what's the status of the build, links to repositories, where they are located, links to builds if they fail, where's the log, and what was the information for that specific build. And we decided to make like throughout a whole infrastructure, just use conventions for everything. So our API is normalized. So the Shaman API, which is just a dashboard, but it has also a little bit of API. The API on how to get to a specific SHA-1 of a specific branch of CentOS 7 with no tcmalloc enabled how to get to that build is the same that you get to other systems that are put into like the overall infrastructure that we have to maintain these. So the other thing was that we did automatic server pools, and for these specifically, what it means is that we were able to fire up all of these build nodes and automatically join Jenkins. So there was zero interaction. Before, it would take us like between 15 and 20 minutes of manually like, oh man, like we're dragging here, so let's fire up another build node, run these scripts, and make a join into Jenkins and do some work, and let's see how that handles the load. And that was just unsustainable. I didn't want to do that anymore. So what we did was like we built a bunch of automation, and now build nodes were firing up and down, and they were automatically joining Jenkins and be ready to produce some work. The most we've seen is up to like 500 repos per day. So we are able to produce massive amounts of repositories. It's not only Ceph. We have a lot of other projects that started like joining after Ceph that we are also producing, and we're also interested in producing repos for. NFS Ganesha is one of them, for example. I think Ceph Ansible is here, but there's a lot of other projects. And the good thing is, again, it's the normalized API. So if you want to go to Ceph, the master branch, the latest SHA-1, you can go there in the same way that you go for other projects. So we made it go faster. We went from up to a day and a half to initially 45 minutes. With the new dependencies and extra stuff that the Ceph project has been adding, we're now up to an hour and a half. But think about like the exponential shift in speed. So we went from like almost a day waiting for a repo to just 45 minutes. And most of that time was basically spent in creating the binaries. And we're able to scale and make it fast. And by scaling up and down, well, definitely cheaper and more efficient. So and there was order and structure, and when things are following a certain pattern, it's easier to scale because someone else comes into the team and he's new, and it's like, well, these things are very well defined. I can be thrown under the bus. It's not a problem. Like things are there and documented, and you can produce make some progress. So we have these repository called Ceph build, and this is where all of our Jenkins jobs are defined, a bunch of our build scripts. One of the most amazing things about all of these that I said is it's not the scalability, not the elastic stuff, or how everything is documented, but for me specifically was that maintaining all of those by hand up until the point where we started the automation was really taxing, and it was a big burden. But I remember the day when a core developer sent a pull request to Ceph build, basically making an update on one of the build scripts, and I felt fantastic because I was like, here's a guy that really knows what exactly needs to change in the build system, and he's sending a pull request to basically update all of the jobs, including the release and development ones, because he knows exactly what needs to happen. It's no longer me that I have to like, oh man, I have to figure this out because otherwise we're not gonna get a release out. So a balancing of responsibilities was a great achievement, I think, here. So we went from to actually cut a release, it could take us 4 hours. So shifting now a little bit from development to like the actual release cycle. In the beginning, it could take me like 4 hours if I was doing everything correctly. And in the worst case scenario, it was like a week to cut a release, which was extremely stressing. If, for example, imagine releasing Luminous, and we're trying for a week, new things are getting into the repo, and we're just trying to get it out, and like, wow, so we're already past, we're so behind that things are getting in there, and we get merge conflicts when we're trying to publish the tag. So I think we've made a lot of progress.
Cool. So there are really an entire constellation of projects that are surrounding Ceph, and I'm sure that different projects come to your mind when I say that, but everything from the kernel client all the way to QEMU, simple things like FIO, into even some of the newer stuff like Rook and Kubernetes. This universe is expanding of the ecosystem that's around Ceph. And so keeping track of all of that and making sure that those things are building and the changes that we make don't break those things and the changes that all of those projects make don't break us. We want that user experience, the whole user experience, to be as good as it can be, as well documented as it can be, and so on. But tracking all of that is a challenge. Like Alfredo was saying, we want to add more and more of those things, like Rook and the CSI projects and these kind of things. And so that it's basically these things are expanding in several dimensions. The list of projects is just one of them, and the architectures is another one. So Alfredo, you can speak real briefly about the ARM.
Yeah, so we had issues with the ARM builds. We used virtualization. We were using OVH, I think, at some point to produce the nodes to build. And we wanted to get ARM builds out. So the first initial strategy was like, oh, let's use OpenStack to get some ARM VMs. And it turns out you can't, because it's tied to the architecture of the host. If there are no hosts with ARM that can provide virtualization, you can't virtualize and have virtualized VMs on ARM. So we're like, we can't. And then I was trying to find the name of the company that helped us out and donated ARM servers. So we have a couple of ARM servers that were donated to produce builds, and we use those. And we were able to finally produce builds based on ARM, but these are actual physical servers. Now, it's a challenge, because sometimes like these, basically they are very slow because of the ARM architecture, and building Ceph takes a while, and sometimes they fail, and it's hard to keep up with. But like this is another, like Ken was saying, this is another thing in the matrix of building all of Ceph that makes it really, really tricky.
So another thing that is also expanding is just the number of artifacts and the type of artifacts that we're trying to push and support. So when with the older releases, it could be older versions of Ubuntu or CentOS, all the way into like newer types of content like containers, and not just a single Ceph container, but also the Rook container and the CSI containers. That's just it's basically going to expand further and further. But basically, what the point of what I'm saying today really is that, and this is we're getting into like the forward-looking statements here, but basically, I want this build system has been able to scale really well. Like we've had up to 500 repos a day, that type of load. We've tried like integrating with different OpenStack environments or different things, and oftentimes it just ends up like melting down some of these systems. But I think we need to scale this even further to be able to take on the newer challenges. And so really, I want to make our build system more pluggable for third parties to integrate with. And I'm going to talk really briefly about 2 ways that I kind of see that happening. So, the old way was really like you were describing, like SSH into the system, or just give root access to whoever to go like log in and fix whatever you need, ninja style. And the new way is really like where we're headed is with well-documented APIs and integration points for building Ceph on the platforms that you care about. So a really great example of this so that I want to extend even further is with the FreeBSD stuff, where we have a member of the community that really cares about making Ceph work on FreeBSD, and so he runs his own Jenkins instance in order to build FreeBSD artifacts. And I think that that is a great model because he is so close to the platform that he's able to solve the integration issues a lot more quickly than our team can. So really practically, that currently what that would involve is like setting up polling. So I think that his setup in this example uses polling for GitHub. And polling the world is very inefficient, especially when it comes to pull requests and these type of things. So basically, there is the Fedora project, which is a project that builds the Fedora Linux distribution, and they have a message bus, the Fedora message bus, and this, one of the integration points for this allows you to send all GitHub events into this message bus. So that way, any consumer can connect to this bus and receive events. So when we create pull requests in Ceph, when somebody comments on a pull request, when they, CI passes or whatever, these events get sent on the bus. And then there's also a Jenkins plugin for this that a lot of teams in Red Hat use that allows us to listen for these type of messages, filter them, and trigger events on the ones that we care about. So that is actually live. Today we're sending all the Ceph messages to the Fedora message bus. So basically, I really see the next level of scaling this instead of just having like a single Jenkins or a very restricted Jenkins to having like a federated system of Jenkins or listeners that will be able to build even more things. And then the second thing that I see as an opportunity for integration is really the community build systems. And like I said, we are building like a ton of things all the time. And Ceph, it takes a very long time and it's very CPU intensive to build. And it's getting longer and longer as the new releases go on. But I think traditionally when we've gone to these different community build systems and said, hey, can we just build 400 repos a day? They either say, please go away, or or maybe we've tried it and things are breaking already, and they say, please stop, please turn that off. What are you doing? And so I really do think that there's got to be a middle ground between like all or nothing, and I think that maybe that would look like building some branches or point releases or something like that. Basically, one of the ways in particular that I see that working out is with the CentOS community has a community build system that's available for any open source project. And there have been some members in the CentOS community that have built Ceph in this for a very long time. I think that we could integrate even more deeply with this. And there's more information about this on the wiki, but basically, that would give us a lot of things kind of for free that we have been doing for several years with like signing, and pushing gigs and gigabytes of packages, and also the different architectures as well, like ARM, PPC, 64LA, and these kind of things. So I really do think that having our build system more pluggable is going to be able to take us into the next level, into next year and beyond. Yeah. Let's go over the lessons learned.
So I think there are a bunch of lessons learned. I think I went through a couple. I think we were able to pull through trying to build something that scaled for our team. Like Ken mentioned, the next milestone is how to federate this, expand it, and open our API so that we can receive builds from others. The FreeBSD example is perfect for this. I think that I kind of failed at not seeing that as, why don't we think about this from the start and put these things into place and make that happen. But part of the, I think, lessons learned is like, thinking about the community first in an upstream kind of fashion. I think it was one of the things that made me think about how to make this work for everyone else without that necessarily meaning, let me, yeah, sure, I'll have to learn FreeBSD so that we can produce builds for the community when that's already happening. It was a humbling experience because you're doing work that everyone is everyone is benefiting from. The hard work from the developers is exemplified at the end for a repo or a build, and if that's not installable, it's on you. So definitely humbling when you're putting a lot of good work on these, and someone is being able to install Ceph and have a good experience. That's great. And when they don't, because our signing process missed an RPM or a deb, and the repo is kind of incomplete and it crashes or it just fails, that's really hard. So we're always trying to improve there.
Cool, and that's it. How about, does anybody have any questions? Sure. Sure, I can. Yeah, I'm going to go ahead and repeat Guido's question here. Was basically, it's getting more and more tricky to build Ceph on your own outside of some of the infrastructure that we've described here today. Does that reflect what you said? Okay, sure. I agree with you. It is very tricky to build Ceph. It typically melts down my laptop every time I try to do it. But apart from that, in terms of just the step-by-step instructions, yeah, we could definitely do a better job of highlighting that in the README for Ceph, as well as I think there might be some researcher tech docs about this thing. Yeah, we need to do a better job of that. I think that, Alfredo pointed out the Ceph-build repository is the canonical location for all of the stuff that's running in Jenkins. Like if you want to see how we're building Ceph, you can just look in GitHub and see that's all of our Jenkins configuration is in the open. Does that answer the question? Sure. Yes, it would. Sure.
Yeah, so the question is to give an example of how this federated idea would work in the future. So I think one of the ways is that we have this dashboard called Shaman, and it receives API notifications of all of the build systems available, and that's restricted. That's our systems, that's our nodes building for the distros and architectures that we want in a specific way. So I think one way that we see that is, again, using the FreeBSD example, is we would allow with certain specific permissions the FreeBSD maintainer to push updates to when he can cut releases, and he can have development builds push notifications into the dashboard so that other members in the community can benefit from that. Yes.
So I think the question, if I heard correctly, was there's been incidents in the past where we pushed a release and then we emailed the users list saying, "Oh, that's a really bad release. Don't touch that one." I think, Alfredo, you're going to stop writing bug-free code any day now, right? I think that's a really tricky problem to solve once you push something to unpush it. I think that I would I can answer for myself. I would like to make the release process a lot more lightweight, so that it's simply a matter of you just roll forward, tag again with a newer version that's higher, and make that process lighter weight and then asynchronous in terms of like the builds are coming, instead of, I think some of the delays that you've seen have been like the process is a lot faster but still not fast enough. All right, thanks a lot, everybody.